All right, so we're going to start chapter 1, section 4b. We're going to solve quadratic equations by completing the square. All right, so by now we should know how to find the solutions of quadratic equations by both factoring and by taking the square root. All right, if you're good with taking the square root, then the only maybe complicated thing here at first is getting the equation to look like something where you're able to take the square root. All right, and you'll see what I mean in a minute. All right, so these are the steps to solve by completing the square. As you can see, it's very wordy, right? So we're gonna go through the steps as we go along, right? And you'll kind of see the steps, and it's essentially the same process every time. Right, so again, the only maybe difficult part is getting the equation to look like something where you can take the square root of both sides, right? But we'll do that in some examples now. All right, so we see 3 examples on the screen. Now, looking at the first one, your instinct with all of these should be to check if you can factor, right? Now, something like x squared minus 4x minus 14, you might think you could be able to factor it, but if you check, right, factors of negative 14 that add to negative 4, there are none, right? So we want to solve this one by completing the square, right? The only other way to do it is by the quadratic formula, but that's in the next section, right? So that's off limits right now. If you know it, don't use it yet, right? We're going to solve these problems by completing the square. Now, the first step is we want to get all of our constants to one side. All right, so step 1, we want ax squared plus bx equals some number. All right, so we want our constants on one side and then ax squared plus bx on the other side. Here we have x squared minus 4x. We're going to treat that as our ax squared plus bx. And we're going to get the 14 to the other side. So plus 14 plus 14. And then we get x squared minus 4x. And I'm going to leave a little space right here. Equals 0 plus 14 is 14. And again, I'm going to plus a little space right here. Right? And same thing here. I'll add a little plus, and you'll see why in a minute. Right? And then the next thing we want to do, right, this is what we want to add. We want to add b over 2 squared to both sides. All right. Now, our b term here is going to be this negative 4, right? So we want to find negative 4 over 2 squared. Negative 4 over 2 is going to be negative 2. And when we square that, we get positive 4, right? So we want to add 4 on both sides. That's what's going to go in this little space. In class, I showed you guys a box, right? Box, space, doesn't really matter. Right, as long as you know you're adding the exact same thing on both sides, right? Because what you do to one side, you have to do to the other. If we're adding 4 on this side, we have to add 4 to this side as well. All right? And then after that, the whole point of doing this is because we want to factor a perfect square trinomial. Square trinomial. Right, using b over 2. All right. Now, b over 2, what we just found was going to be this negative 4 divided by 2, which got us this negative 2 right here. Right? Now, if you didn't recognize that, you could look at this side of the equation and ask yourself, how does this factor? Right? This is actually something that's able to be factored. Right, so factors of positive 4 that add to negative 4 is going to be negative 2 and negative 2. So we're going to get x minus 2 times x minus 2, right? But isn't that the same as just doing x minus 2 squared, right? You guys agree with that, right? And this is going to equal 14 plus 4 is going to be 18, right? So this is what we have so far, right? The whole point of adding this 4 on both sides was to factor a perfect square trinomial, right? So really we got from this step to this step. All right. And now the next thing we want to do, right, square root both sides. right? So we want to take the square root to cancel out the square, right? We discussed it in the last section, right? Getting rid of a square term, we want to take the square root. So we get x minus 2 equals plus or minus square root of 18, right? Don't forget that plus or minus. All right, and then the last thing we want to do, just solve for x and then simplify. All right, so we want to add this 2, right? Let's solve for that x. We add 2, we get x equals 2 plus or minus the square root of 18. And then we want to simplify this a little bit, right? So we want to split up square root of 18, right? Square root of 18 becomes the square root of 9 and the square root of 2, right? We want to simplify, get a perfect square out of that factor. So we get x equals 2 plus or minus 3 square root of 2. All right, and that's our final answer. And this is completing the square, right? So it's going to be the exact same steps every time. This is what I'm going to do, at least in these few examples where our a term is 1. All right, so let's try number 2. Again, your instinct should be to factor, right? So if you want to try it for this one, you're going to notice that this one doesn't factor, right? There are no factors of -1 that add to +6, right? So this one, we want to complete the square, right? Again, the first thing we did, we got the ax squared and the bx on one side, and we got the constants on the other, right? So I'm not going to write all the words down. You guys can look at that, right? I'm going to add the 1 on both sides. So we get x squared plus 6x, right? And then plus a little box, or plus a little space, whatever you want, equals 0 plus 1 is 1, and then plus the little box. All right. What was the next thing we wanted to do? We wanted to add b over 2 squared to both sides. Right, so the second step, let's add b over 2 squared. Our b term here is the 6, right? So 6 divided by 2 is going to get you 3, and 3 squared is 9, so we want to add 9 to both sides, right? And we should get x squared plus 6x plus 9 equals 1 plus 9 is 10. All right? And then the third thing we want to do is we want to factor a perfect square trinomial, right? X squared plus 6x plus 9 is going to factor as x plus 3 times x plus 3, but that's the same as x plus 3 squared, right? And that equals 10. All right? And now, again, another way to get this 3, right? Sometimes, and you'll see in some other examples, we're not going to be able to nicely factor it and list out all the factors, because sometimes we get fractions, right, in this little space right here, right? So sometimes we get fractions and we don't want to have to try to factor that. The other way that you can do it, besides having to factor it, by memory, what multiplies to this and adds to this, is going to be, you're going to add your b over 2 term every time, right? So x plus 3, we also got from doing 6 divided by 2, right? And that gets you this 3. 6 divided by 2 squared is what we added, right? But also 6 divided by 2 we can just write in front of this x, right, to get x plus 3 squared. All right, the fourth thing we wanted to do was take the square root of both sides. All right, and that cancels out this square. So then we get x plus 3 equals plus or minus square root of 10. All right, the fifth thing we wanted to do is to get the x by itself, right? So subtract 3, we get x equals -3 plus or minus the square root of 10. All right, and there's your answer, because you can't simplify square root of 10 anymore. All right, so you can just leave it alone like this, right? And that's completing the square. All right, so now looking at number 3. Again, going through these steps as normal, right? We want to get the x squared and the bx to one side. So we want to add 5 on both sides. plus a little space equals 0 plus 5 is 5 plus a little space. All right, the second thing we want to do is we want to add b over 2 squared to both sides. Our b term here is 2, right? 2 divided by 2 is 1, and 1 squared is going to be 1. So we're just adding 1 to both sides. So we should get x squared plus 2x plus 1 equals 5 plus 1 is 6. And then we want to factor the perfect square trinomial, right? You could know that x squared plus 2x plus 1 is going to factor as x plus 1 squared, or you can just find your b over 2 term and throw it in front of your x, right? So we get x plus 1 squared equals 6. All right, and then the fourth thing we want to do, square root both sides. All right, the square root cancels with the square, so we get x plus 1 equals plus or minus the square root of 6. And then the fifth thing we want to do is solve for x. So subtract 1 on both sides, we should get x equals -1 plus or minus the square root of 6. And square root of 6 doesn't simplify any further, so we can leave our answer as this. All right, so let's keep going with a couple examples. Now, something like number 4, hopefully you're looking at it and you can recognize that this is something that can be factored, right? So x squared plus 7x plus 12. If you want to solve it by factoring, right, that completely works here, right? So we want to find factors of 12 that add up to 7. All right, it's going to be 4 and 3. So we should get x plus 4, x plus 3 equals 0. And then once you have these factors, you can use the 0 factor property, right, and set them both equal to 0. And then we get x is -4 and x is -3, right? So that works here, but we're learning how to complete the square. So let's try it that way, right? And keep these answers in mind, right? Because you'll see that we're going to get the same answers at the end. All right, so let me get rid of this. We're going to solve this by completing the square. Now, the first thing we always want to do, get our ax squared and our bx terms on one side and the constants on the other. All right, so let's subtract the 12, subtract the 12. We should get x squared plus 7x plus, right, don't forget your little box, equals 0 minus 12 is going to be -12. And then again, plus your little box. What you do to one side, you have to do to the other. Second thing you want to do is you want to add b over 2 squared on both sides. Now, in this case, b over 2, our b term is 7. All right, so we have 7 over 2 squared. So this is what we're adding on both sides. Now, hopefully we remember how to square fractions, right? You can either just multiply it. I'll do it up here. You can either just do 7 times 2 times 7 times 2, literally multiply it out twice. And then when you multiply fractions, you want to go straight across. So you get 49 over 4. All right. So that works, but another way to do it, right, is if you have a fraction squared, the fraction can go to the top and the bottom. So this becomes 7 squared over 2 squared, right? Quite literally the same thing that we get up here, right? So let's just go ahead and add that, right? So we're going to add 49 over 4 to both sides. All right. And then the third thing we wanted to do is we wanted to factor the perfect square trinomial. All right, now this is a case where you maybe not want to think of factors of 49 over 4 that add to 7, right? So this is a case where you would just use b over 2, right? Any perfect square trinomial when you're factoring or when you're solving by completing the square is always going to look like x plus b over 2 squared, right? And b over 2 in this case was this 7 over 2. Right, so this is going to become x plus 7 over 2 squared, all right, and this equals -12 plus 49 over 4. Let's go ahead and add that now, all right, just to get it out of the way. right? And now to add fractions and whole numbers, you want to make sure they have the same denominator. So let's put it over 1. And then let's multiply the top and the bottom by 4, right? So we should get negative 48 over 4 plus 49 over 4. All right, so then this should become, I'll write it down here, x plus 7 over 2 squared equals, and negative 48 plus 49 is just going to get you a positive 1 over 4. All right, so we're at this step now, right? Everything is already simplified. We have a perfect square on one side, a constant on the other. So now we just want to, the fourth step, square root both sides. All right, cancel the square root in the square. And then we should get x plus 7 over 2 equals plus or minus square root of 1 over 4. And then the fifth thing you want to do is solve for x and simplify. So let's subtract 7 over 2 on both sides. And then we get x equals negative 7 over 2 plus or minus the square root of 1/4. All right, you can't leave it like this. You can simplify it. Right? Don't forget to simplify radicals that have fractions, right? You can just square root the top and then square root the bottom. All right, so that becomes that and that becomes that. All right, so then we should get negative 7 over 2 plus or minus the square root of 1 is 1 and the square root of 4 is 2. All right. Now, if you're able to simplify further, you should simplify further. All right, so this should get you two answers, right? Negative 7 over 2 plus 1 over 2 and negative 7 over 2 minus 1 over 2. Now, these have the same denominator, so you're able to combine them, right? Negative 7 plus 1 is going to get you negative 6 over 2, and that's going to get you negative 3. So that's one of your answers. And then we get negative 7 minus 1 is going to be negative 8 over 2 is going to get you negative 4. All right, so we get two of our answers. And if you remember, these are exactly the answers that we got from the very beginning just by factoring. All right. Now, of course, if you had to pick, you're probably not going to pick completing the square, right? That's way too much work for this problem. If on a test or a quiz, the problem just says to solve, then you can solve using any method you want. If we want to get specific and we tell you specifically solve by completing the square, then you need to take this route and you have to solve by completing the square. All right, so you need to know both ways to do it. All right. Okay, let's try number 5. Again, you want to get your ax squared plus bx to one side, your constants on the other. First thing you want to do is add 6 on both sides. All right, so we get x squared minus 3x. All right, add your little box. Equals 6. Again, add your little box. All right. The second thing you want to do is add b over 2 squared to both sides. In this case, b is negative 3. And then, again, just like the last one, I'll do that up here. Negative 3 over 2 squared. Right? To square this, you can square the top, square the bottom, or just do it twice, right? Negative 3 over 2 times negative 3 over 2. Should get you positive 9 over 4. Right, so that's what we're adding on both sides. We're adding 9 over 4 plus 9 over 4. All right, and then the third thing we want to do, or let me go ahead and write this out fully. All right, so we get x squared minus 3x plus 9 over 4. And then this equals 6 plus 9 over 4. We can write it under a 1 and then multiply the top and the bottom by 4. All right, so we get 24 over 4 plus 9 over 4, right? And that gets you 33 over 4, right? But I'll write that in the next step, right? So the next step is you want to factor your perfect square trinomial, right? And again, to do that, it's going to be x plus b over 2 squared, right? And b over 2 in this case is negative 3 over 2. So we're going to get x minus 3 over 2 squared, right? And that's the same thing as this up here, right? It's the same thing as this x squared minus 3x plus 9 over 4. And then equals 22 over 4 plus 9 over 4 is going to get us 33 over 4. All right, and then the fourth thing we want to do is square root both sides. So we should get x minus 3 over 2 equals plus or minus the square root of 33 over 4. And then the fifth thing we want to do is solve for x, simplify. All right, so we want to add 3 over 2 on both sides, right? So plus 3 over 2 plus 3 over 2. So we get x equals 3 over 2 plus or minus the square root of 33 over 4. And now we want to simplify this further, right? You can't leave it alone like this. You need to make sure the radical is fully simplified. So we get x equals 3 over 2 plus or minus, right? This is the same as square root of 33 over square root of 4, right? And square root of 4 is just 2. So we get 3 over 2 plus or minus the square root of 33 over 2. And then square root of 33 can't simplify anymore, so you just leave it alone. This is your answer. All right, another equally correct way that you can write your answer is if you notice that the denominators are exactly the same, then you can write it under one fraction. All right, so then you get 3 plus or minus the square root of 33 over 2, right? That's also equally correct. Either way is correct. All right, and now let's try a couple more. 6 and 7 are a little different because these are not the cases where we have nothing in front of our x squared, right? There's actually one thing that we want to do first, right? Before we do anything, right? I know I go through the 1, 2, 3, 4, 5, those steps with you guys. There's actually one little pre-step that we want to do, right? So the first thing that you want to do, the actual first thing, is divide the 9 everywhere, right? Completing the square only works, at least in this case, when your first term is just an x squared, right? So that's actually the first thing you want to do is rewrite the entire problem, right? So divide a 9 everywhere, right? Then 9 and 9 cancel out, and then we get x squared minus, and then 12x over 9 simplifies to 4 over 3x, and then minus 1 over 9 equals 0 over 9 is just 0. All right, now let's go through all of our steps. All right, so the very first thing we want to do, as always, right, get your x squared and your bx to one side. So let's add 1 over 9x. Or no, just 1 over 9, sorry. And then we should get x squared minus 4 over 3x. All right, put your little box, equals 1 over 9 plus another little box. All right, second thing you want to do is add b over 2 squared to both sides. In this case, b is negative 4 over 3. All right, so negative 4 over 3, right? Dividing by 2, if you divide by 2, you're going to have to multiply, or you're going to have to keep, change, flip. You'll have a fraction divided by a whole number, right? But don't you guys agree? The same thing as dividing by 2 is multiplying by a half, right? That's exactly the same as dividing by 2, right? So we multiply this fraction by a half, and this is much easier to simplify, right? You can just simplify the 4 and the 2, and you should get 2 up top. So then we get negative 2/3 squared, right? And then square the top, square the bottom, we should get 4 over 9 on both sides. All right, so let's add 4 over 9 on both sides. All right, so then our second step becomes x squared minus 4 over 3x plus 4 over 9 equals 1 over 9 plus 4 over 9 is going to get you 5 over 9. All right, the next thing you want to do is factor your perfect square trinomial. All right, again, use b over 2, right? Don't try to find factors of 4 over 9 that add to negative 4/3. No, right? You want to use b over 2. You get your perfect square right away. So x minus 2 over 3 squared equals 5 over 9. All right, and then the next thing you want to do, square root both sides, right? After you take the square root of both sides, the square root and the square cancel out. Then we get x minus 2/3 equals square root of 5 over 9, plus or minus, right? Don't forget the plus or minus, like I just did. All right, the last thing you want to do is add 2/3 on both sides. All right, so then we get x equals 2/3 plus or minus square root of 5 over 9. All right, and then you want to simplify the radical, right? You can't just leave it like that. So we get x equals 2/3 plus or minus, right? Square root of 5 over 9 is the same as square root of 5 over square root of 9. And then we get square root of 5 over 3, right? Square root of 9 is just 3. All right, so this becomes our answer here. And then just like the other problem, we can make this into one single fraction, right? Since our denominators are the same, we can equivalently write x equals 2 plus or minus the square root of 5 over 3, right? That's equally correct. All right, and now let's try number 7. Right, number 7 is a similar one. There's one thing we want to do first before we start the steps that we've been doing for all these problems, and that is get rid of the number in front of the x squared. Right, so to do that, let's divide everything by 3. Right, divide by 3, by 3, by 3, and by 3. All right, so this 3 and this 3 cancel. We should get x squared plus 2x over 3 just stays. Right, you can write it 2 over 3x, and then minus 5 over 3 equals 0 over 3 is just 0. All right, so now let's go through our steps. Same as always, right? First thing we want to do, get our ax squared and bx by itself. All right, so let's add 5 over 3 on both sides. All right, so we get x squared plus 2 over 3x, and then plus a little space, equals 5 over 3 plus a little space. All right, the second thing we want to do is add b over 2 squared to both sides. Again, we have another fraction. If we do 2/3 divided by 2, that's the exact same thing as multiplying by a half, right? And in this case, that'll be much easier, right? Cancel out the 2's. Then we get 1/3, and then when we square it, right, square the top, square the bottom, we get 1/9, right? So let's add 1/9 to both sides. All right, and then this becomes x squared plus 2 over 3x plus 1/9, and then 5 over 3. You can multiply the top and the bottom by 3 to get the same denominator. All right, and this becomes 15 over 9 plus 1 over 9. All right. Next thing you want to do is factor your perfect square trinomial. Right, so x squared plus 2 over 3x plus 1/9 becomes x plus 1/3 squared. Right, equals 15 over 9 plus 1/9 is going to become 16 over 9. Right. And now if you don't know how I got this 1/3, again, in all of these, to get from step 2 to step 3, it's just going to be x plus b over 2 squared. Right, b over 2 in this case is 1/3. Right, and you want to square the entire thing. All right, the fourth step, you want to square root both sides. All right, square root, square root. All right, so this cancels with this, and then we get x plus 1/3 equals plus or minus square root of 16 over 9. All right. And then the last thing we want to do is simplify. Solve for x and simplify. So we get, we can subtract 1/3 on both sides, so we get x equals negative 1/3 plus or minus. Square root of 16 over 9, you can split it up, right? Square root of 16 over square root of 9. And these are both perfect squares. So we get negative 1/3 plus or minus 4 over 3. All right? And we don't have radicals in the top. We have only rational numbers, right? No radicals. All right, so we can actually split this up and solve and get two rational number solutions, right? So we should split it up, right? Anytime you're able to split it up, you should. You should get 1/3 plus 4 over 3, right? And negative 1/3 minus 4 over 3. All right, so in one of our answers, all right, let me write darker, you might not be able to see that. This is going to equal, all right, negative 1 plus 4 is 3. Divided by 3 is 1. And then negative 1/3 or minus 4/3 is going to be negative 5 over 3. All right, and you can just leave that alone. So you get your two answers. All right, x equals 1 and x equals negative 5 over 3. Right, there were no radicals here, right? So you probably could have factored this also, right? Factors of negative 15 that add to 2 are going to be positive 5 and negative 3, right? And you could have factored it, split it up by grouping. That maybe would have been a little bit easier here. But again, we're trying these problems by completing the square, right? We need you guys to practice these skills to be able to solve any problem that comes to you. You can have a choice as to what method you want to pick. All right, so again, the answers for this one, we got 1 and negative 5 over 3. All right, let's finish up with these last three examples. All right, so number 8, just like the others, we want to get rid of that 3 in front of that x squared. All right, so the first thing we want to do is divide everything by 3. All right, divide everything by 3. And then cancel everything out. We should get x squared minus 4 over 3 x minus 1 over 3 equals 0 over 3 is just 0. All right. And now we can go through our steps as always, right? We want to get our constants on one side. So x squared minus 4 over 3 x plus a little box equals 1/3 plus a little box. All right, we added 1/3 to both sides. All right, and then second thing is we want to add b over 2 squared to both sides. In this case, b is this negative 4/3. All right, so negative 4/3, and then dividing by 2 is the same as multiplying by 1/2. So let's do that here since we have a fraction. All right, cancel out the 4 and the 2. We get 2 over 1. All right, equals negative 2 over 3. And then we want to square this. All right, so squaring negative 2 over 3 should get you 4 over 9. All right, so add 4 over 9 to both sides. All right, so then we should get x squared minus 4 over 3x plus 4 over 9 equals, and then 1/3 plus 4 over 9, we can multiply the top and the bottom by 3, right, to get a common denominator. So you get equals 3 over 9 plus 4 over 9, and then I'll add those in the next step. All right, the third thing you want to do is factor your perfect square trinomial. Right, so remember, to get from step 2 to step 3, we always are going to do x plus b over 2 squared, right? That entire thing squared. In this case, b over 2 is negative 2/3, so it's going to be x minus 2 over 3 squared. And then equals 3 over 9 plus 4 over 9 is 7 over 9. And then the fourth thing we want to do, square root both sides. All right, the square root cancels with the square. We get x minus 2/3 equals plus or minus square root of 7 over 9. All right, and then the last thing we want to do is solve for x and simplify. All right, so let's add 2/3 to both sides. We get x equals, all right, these cancel out. We get x equals 2/3 plus or minus the square root of 7/9. And then square root of 7/9 can simplify, right? Square root the top, square root the bottom. We get x equals 2/3 plus or minus the square root of 7/3. All right, and then that should be your answer. And then again, just like the others, since you have the same denominator on both fractions, we can write it under one fraction. Again, this is equally correct. All right, I know some of you like to ask me, am I going to lose points if I do it one way? No, these are both correct. All right, one way or the other. All right, as long as you get your final answer and it's fully simplified, all right, that's all I care about. All right, so either of these are correct. All right, just two more. So let's keep going. Number 9, the very first thing we want to do, right, is to get rid of that 5 in front of the x squared. All right, so let's divide 5 everywhere to each term. All right, so we should get x squared minus 7/5x minus 1/5 equals 0/5. All right, and now we go through our steps, right? First thing we want to do is add 1/5 to both sides. So we should get x squared minus 7/5 x. All right, make sure you leave a space. Equals 1/5 plus, again, leave a little space. All right, second thing you want to do is add b/2 squared to both sides. Now in this case, b/2 is going to be negative 7/5 times 1/2. Right, and then multiplying by half. Nothing cancels here. Right, so we're just going to get negative 7 times 1 over 5 times 2 is going to be negative 7/10 squared. Right, and this is going to get you negative 7 times negative 7 is 49. 10 times 10 is 100. So we're going to add 49/100 to both sides. All right. So then we get x squared minus 7/5x plus 49/100. All right, equals, all right, you don't have to write it twice like I'm doing. I'm just writing it twice so that I have a clear, concrete next step that I'm doing. All right, but you don't have to write it twice. It's a little redundant, honestly. So that's up to you. And then on the other side, 5 and 100, they have a common multiple of 100. So let's multiply the top and the bottom of this fraction by 20. All right, because we want the same denominator. All right, so then we get 20/100 plus 49/100. All right, and now the next thing we want to do is factor our perfect square trinomial. All right, so then it becomes x minus 7/10 squared. Right, if you don't know how I got this minus 7/10, it was our b/2 term. Right, so to factor from step 2 to step 3, we're just going to do x plus b/2 and square that entire thing. And then on the other side, we do 20 plus 49 is going to be 69/100. All right, and then the next thing we want to do, the fourth step, is we want to square root both sides. So we get x minus 7/10 equals plus or minus the square root of 69/100. Right, the last thing we want to do is get the x by itself, right? So let's add 7/10 on both sides. So we get x equals 7/10 plus or minus the square root of 69/100. All right, and now we want to simplify the radical. So we get x equals 7/10 plus or minus the square root of 69 over the square root of 100. Right, you could probably do it in less steps if you can recognize what's going on here. Right, I'm just writing it out so that you guys can see it. Right, so this is going to be x equals 7/10 plus or minus the square root of 69/10. And then I don't believe 69 has any factors that are perfect squares, nor is it a perfect square itself, so we can leave this as our answer. And then just like the other ones, because they both have a denominator of 10, you can write it under one denominator of 10. Right, and these are both equally correct. All right, just one more. Just like the others, we don't see a number in front of the x squared, right? But we see a negative, right? Again, just like the others, we only want the x squared, right? So let's get rid of that negative. Let's multiply this entire equation by -1. And that's just going to change the sign of everything, right? So we get x squared minus 3x minus 5 equals 0 times -1 is, again, just 0. All right, and now let's go through our steps as always. All right, let's get the 5 on the other side. Right, so we get x squared minus 3x. All right, let's add a little space, equals 0 plus 5 is 5. Again, add a little space. The second thing you want to do is find your b over 2 term and square it, add it to both sides. In this case, b over 2 is going to be -3 over 2, and when you square it, you should get 9 over 4, right? So we're adding 9 over 4 to both sides. All right, and then the next thing you want to do is to get from step 2 to step 3, you want to factor your perfect square trinomial, right? By doing x plus b over 2, and then squaring that entire expression. So in this case, b over 2 is -3 over 2, so we get x minus 3 over 2, square that entire thing, and this is equal to 5 plus 9 over 4, right? With this one, we can multiply 4 on the top and the bottom. So we should get 20 over 4 plus 9 over 4. All right, the fourth thing we want to do, or I'll continue simplifying this a little bit. All right, so this is going to be x minus 3 over 2 squared equals, and then 20 over 4 plus 9 over 4 is going to be 29 over 4. All right, and then the next thing you want to do, all right, so step 4 is going to be to square root both sides. So we get x minus 3 over 2 equals plus or minus the square root of 29 over 4. All right, and so the last thing you want to do is solve for x, right? So add 3 over 2 on both sides. All right, so we get x equals, these cancel out, we get x equals 3 over 2 plus or minus the square root of 29 over 4. And then this is the same as saying x equals 3 over 2 plus or minus the square root of 29 over 2. All right, square root the top, square root the bottom. And then this is our final answer, but this is also the same as saying x equals 3 plus or minus the square root of 29 all over 2. All right, these are both equally correct. All right, and you always want to check if the radicals simplify any further. In this case, 29 does not simplify any further, so you leave it alone. And then these would be your answers. All right, so you can see that some of these, especially when the middle term is a fraction, require a considerable amount of work, right? So this is really especially useful, right? So completing the square, solving by completing the square is useful when we have an x squared, so an x squared with nothing in front of it, because then you don't have to divide by that number in front of it and then risk the possibility of getting fractions. So it's useful when we have an x squared and b is even, right? Because when b is even, and we saw it in the earlier examples, when b is even, we don't get those fractions and we get nice perfect square trinomials, right? Ones that are pretty easy to factor, right? So this is just a little side note. It's useful when we have just an x squared, right? So 1x squared, you can think of it like that, and b is even, right? But in all of these other ones, we got solutions from using, from completing the square, right? Once we learn quadratic formula, maybe you like that a little more, but again, we're showing you all the methods so that you can kind of play around with it and see what you like. All right.